All right, thanks for watching. Probably gonna dip all over the place here. Um, but yeah, I cannot just stay on the confined atom or the Higgs. Is it the Higgs, where you're basically talking about Higgs would essentially be, you're talking about the cosmic soup and the particle theory. You're just talking about forces in motion and equal and opposite motion. And yeah, I was trying to do it, but I couldn't do it, and I couldn't really wrap my head around. Uh, well, I mean, I can't look like really wrap my head around like the most basic laws, I guess. I mean, it is interesting to me. My understanding of Cartesian theory is that um, you have infinite width and infinite height, um, or well, yeah, the infinite width and the infinite height in things are essentially the that's what the barometer is gauging like for time, which is interesting because you can kind of understand. Like I was thinking of the not circular space but topological space where you essentially have like an infinite um, wall, or it's almost like the wire conductor, the transformer, where you just have a switch, and it's like that switch is almost in proportion to uh, your topological theory. Well, essentially, I guess in topology, of course, they have um, like that's essentially the second dimension, where you have the first dimension and then you have the second dimension, and you have different variants of dimensions there. Um, I mean, I wouldn't say I don't really think in terms of like having Cartesian and Newton's and Einstein, or well, classical and quantum mechanics, and then string theory, essentially trying to connect them all, and um, like an artificial intelligence idea where you're trying to construct like essentially like a constructor theory for microbiology, or evolutionary microbiology, and you're trying to say, well, how did the prokaryote, how did the single cell connect with the eukaryote, the multicellular organism, and like you can't really have these. I mean, fundamentally, like even like these staircase theories, um, unless you're just talking about like how they're just sort of gelatin and cells and such. We know that they're just like essentially that their texture is just elasticity, and the elasticity is essentially fluctuation of the temperatures, I would say. So there's so much fluctuation of temperature. Like if I take a piece of, like if I take a piece of skin off, it just goes to room temperature, but my body is able to maintain a uh, certain temperature for my body. So how do you really like understand the separation that is between, I guess, the subatomic bits and the laws of physics, quantum mechanics, and like how do you make these Cartesian staircases, the polarization of them? How do you make those? How do you turn it into permittivity? Like how do you have your epsilon, or I think it's the epsilon, and um, you kind of have to you kind of have to like logically say, well, it's definitely going to take this like column atom, or the column phase. Like you can't have confined spaces. I mean, there's all these phases, right? Like you're essentially, again, doing it backwards. Like you go from like understanding Higgs and cosmic soup and how the temperature really is important in this equation, and just the fact that it is going to be unilateral with with inflation, essentially, or sorry, the entropy. And the entropy could essentially be the inflation too, if you think about the temperature rising, bits are colliding, so more and more bits are colliding. I mean, you're essentially just talking about two significant points in time, which I know breaks the physical laws of relativity, but you have to essentially do that to be able to understand that, okay, if the entropy is going up while the temperature is cooling, that means that it's essentially decaying because it had collided more bits. So it is. I mean, I can't really particularize it with anything else other than free energy and just, yeah, a paradox. And the kinetic energy, where you have an electron moving faster than the neutron. The electrons are always moving around the neutron, therefore they have more energy. Um, and if there was to be decay, if there was to be radioactive decay, you're saying, well, they're losing electrons. That means they would essentially gain speed. So if there's only one, I mean, if there's only one electron moving around the neutron, then it has to swirl around really fast. But if there's 100 electrons around the neutron, then all of those are going to be moving very slowly. Like I like I just said, the more electrons you lose, um, the faster the orbits of the electrons will be. That is the paradox. I mean but it's an essential paradigm to quantum mechanics, and to have this like, I don't know, to make it relativistic enough. I mean, well, like, you can't make it relativistic. You can't really have a relativistic wave function, right? Because if you're talking about elasticity a uh, in a plant or something, like the elasticity of cells, which is just this gelatin, um, and I mean, how would you call it? It's like you could say that it needed like heat. Um, it needed heat from like underwater volcanic eruptions. There's underwater volcanic eruptions, that so there yeah, like, I think this is the theory like of evolutionary biology anyway. You have like underwater volcanic eruptions, and the those come in contact with the glaciers. Okay, like, it just everything was glaciers, and now we have our moon, and it's been uh, 500 million years, and then there's volcanic eruptions underground. Um, so essentially, uh, with enough heat and enough glaciers, they created water, and then there was still able to be uh, the molten core of the Earth, essentially, maybe the hottest, maybe like the hottest temperatures on our planet, like lava, mixing with these glaciers enough, and you're talking about the cooling process. So eventually, that cooling process is going to cause more entropy, and somehow, so I mean, essentially, we're not talking about Einstein's miraculous day where, okay, it was perfect temperature. I mean, not to get into the Fermi alien paradox, but I'm just saying, Einstein's miraculous day, where if the sun, rose 1 second later, then the prokaryote would have never been. So we're not talking about that. We're just talking about how there had to have been a law of equivalence, where the law of equivalence was that there was enough cooling and enough, essentially, um, cosmic. Sorry, there was enough cooling and there was enough uh, entropy. Okay, and we can see how entropy is very entangled, just metaphorically, with cosmic inflation. Because cosmic inflation is saying, well, cosmic inflation, you can kind of uh, use that, like you can abuse that and use it with forces essentially. So it's not I guess that great, because especially since the static state Big Bang just gives you like an accurate a completely accurate proposal of how temperature works with entropy. Like the volume of entropy is the lowest um, when the temperature is the hottest, and so I'm saying it's that sort of uh, Hadean era conjuncture that they probably came up with. That they're saying there's just volcanoes erupting right next to glaciers, so there was enough. The temperature was high enough, and then eventually, when there was water and they cooled down, the entropy had to just be exact. And it's a DNA. It's a DNA. It's a DNA symbol. Sorry, it's a DNA. What am I trying to say? It's like the infinity sign. Like that infinity sign. That's essentially how their entropy works, or well, their theory of like relative uh, evolution. So it works like specifically like this. I mean, it just has high temperatures, temperatures cooling, really high entropy, really low entropy. And if we're talking about cells and such, we're talking about cellular configuration. Then that configuration has to be sort of interdependent. It's like on some topological staircase, like just that illusion staircase that never ends, and you just keep walking around the staircase. You walk down it because it's a two-dimensional staircase. I mean, you can make illusions, really specific illusions, out of um, staircases. I mean, you know, like oh, the sun is a circle, so maybe we're standing on a circle or a sphere, and maybe the maybe there's people like standing upside down on the other side of our sphere. So look, I mean, um yeah, I'm just saying there's a lot of conversation to be had, but there's not I guess really a conversation even anymore, because it seems like all the dissidents have backed out. um which is probably because we like got out of the war. I mean, because this would have been a more relevant issue if we weren't. I mean, I know we weren't at war, but like since we backed out of Afghanistan, everything's kind of become like chaotic with vaccines or quarantine. Like that word was never a relevant term before 2019, and now it's the most relevant term in our society. Everybody's quarantined, so I'm just saying. I mean, I'm saying, well, whatever. What I'm trying to say is that I think a lot of relevancy has been taken away by the conversation, just because, yeah, it's been had essentially. I don't really know how. I mean, I'm not trying to focus too much on that, but just because, yeah, I do like this subject. I just can't stay um, in line with some sort of uh, theory, that it's just going to be an elusive staircase type theory in terms of where the bits what the bits are doing, what the bits of matter, like how they formed with like another with more cells, and the cells were just uh, they did their thing to essentially create a prokaryote. Um, but again, somehow there has to be, so it's almost like this. Uh, it's almost like the what is it called? Like the magnet and the lines of induction and all that stuff. Because because essentially, I don't even really understand it that well. Um, well, because you have a magnet and the magnet pushes. Okay, I get it. I get it. So it's like a double-sided magnet, and the magnet pushes the two lines away. Since there's no like color variation, there's no color variation, but you can still see lines of magnet, something like that. Um, but it's like, how did that magnet fuse? So did life derive from is it baramite? I don't really know the exact properties of a mag like a just a small magnet like baramite or baramine or something. Just like different elements and stuff were able to combine, and then like essentially you just have a magnet. But that's the like how do you uh, there'd have to be an extreme amount of force. Well, not like there doesn't have to be an extreme uh, amount of force to be able to especially these magnets. Like there doesn't have to be an extreme amount of force to push them together because I can easily push these magnets together. But I'm just saying, uh, magnets. Essentially have to be some sort of like life giver, I guess, in the artificial intelligence equation where they're trying to understand microbiology or whatnot. There'd have to be some type of magnetic complex. Um, I mean, seems obvious that magnetism has to come before electricity. Um, but also, the electricity is what makes up the parts, the base of the magnets. So that would be tricky for people to understand if they haven't really thought about that in depthly, since the lines of force are technically invisible unless you were to do the experiment. So, like, how do you? Um, the best way to decompose a magnet would be to just smash it, and you smash the magnet, and then it just breaks down. But like, still, all the bits um, are connective, and so. I'm still trying to understand that uh, geometry essentially. Like, if we're talking about because we're talking about metals and shards of shards of metal still having their magnetic forces, and other metals having their magnetic forces. Um, I would imagine that people just use copper because it's more insulative. People just use copper conductors because it's more of an insulated. Well, it has to be insulated, right, to have the induction. So the induction fires through the insulator. I know. Yeah. I don't know. I don't. I should probably explore that more. All right, almost wasn't secular there. Completely secular, but yeah. Yeah, I was looking at Faraday's laws of induction. I know I'd heard of laws of induction, but I don't know if that's from YouTube or from school. Probably, of course, from YouTube. But yeah. I was kind of trying to say that if that's the inductor, like Faraday's inductor, the switch and the transformer, transforming energy through uh, the current, and how it's like the switch is essentially turning the argument into this topological thing where there's this disk and then the magnetism. Okay, so how does this magnetism, the disk can rotate in well, not any direction, but one of two ways. It can go left to right or right to left. Sort of understanding this black hole, like gravity thing. And yeah, so how do you I mean, it gets to this collapsing star thing for me because um, how do you have something being held by magnetism but being pushed by magnetism at the same time, like in turn just simply in terms of our galaxy, like um, having the black hole and then knowing that there's the energy around it, and they call it the toroidal. Um, they call that the toroidal effect, and they also, and then they get to this the etherists get to this perturbation where there is it's the torus. Well, it's not the toroidal effect, but it's the perturbation is essentially what is keeping the density pushing down to Earth. If you're looking special relative to Earth, but if you're looking at the black hole, then there's the toroidal effect. I'm not gonna. I don't. I don't like that because your models aren't specific to what looks like to what the actual objects look like to me. Like the galaxies just don't look like a toroidal. Um, but I do play with them, and I like the way some of it sounds. I would just rather look at things more mechanically, and then obviously it's topological, and you add an extra uh, degree or dimension to classical or quantum mechanics, and yeah, I'm just not seeing like I guess what I should be seeing. It's like if you have the column atom, then the column atom somehow is traversing the element, or sorry, it's sort of infinitely progressing, but it only integrates in a linear fashion. And then if you have a confined space, if you have a confined particle, excuse me, you're talking about how this particle, um, I don't know, I just don't know where they're getting the atomization of uh, magnetism. Like there has to be some other ionization process, ionization process, to be able to have these magnetic bits flow smoothly, which is a little bit disturbing. Um, but yeah, then there's, I mean, because yeah, I mean, I'm not going to be able to get to all that like nuclear decay and all that stuff. If I don't understand how the Faraday, not the Faraday paradox, but the Faraday laws of induction, meaning magnetism, and how magnetism is supposed to be split off, from this switch. But really, they're just saying, well, magnetism is a topological theory, a quantum mechanical theory, essentially, because yeah, it's just like it's just like Wheeler's experiment. Like you have to have a double magnet create both uh, lines of the dielectricity. But if so that's, I mean, that's not really shown. I mean, I'm just saying there's two holes really. But yeah, I'm really losing my gas here. Um, I did not think magnetism was going to be the end all be all. But yeah, so well, yeah, the collapsing star thing, like it's just, I mean, it goes back to the Penrose theory of gravity, essentially, or if it's Cartesian, where there's uh, every point, every every ray of gravity is being duplicated. Like there's a duplication of every ray of gravity that is shooting outwards, like shooting out of me. Inversely, except it's all dependent on mass and weight and uh, and having like actually confining to space. So there has to be some confinement, but so that's more of like the column particle. But then if you have this Higgs thing, well, filling in all the what's filling in all of the like what's the filling in all the potentialities in converse space or whatever. So I mean that's where it like breaks the like the nuclear decays and the temperature and all that, and it becomes really confusing. Like how do you particleize those bits? Even going back to the prokaryote, knowing that essentially, or how do you like force magnetism together? Um, seems it seems like there should be an answer, but yeah, I guess there's just not one. I mean, yeah, I mean, if it's some kinetic energy thing, like I mean, like I was kind of describing kinetic energy as just saying, well, the less bits there are, the faster the bits are going to move in the orbit, or the less electrons there are, the faster the electrons are going to move in the orbit. Excuse me. So if you have magnetism, you're talking about like a planar. Like, well, yeah, you're using a planar, so I guess it's just planar. And yeah, it's not really. I mean, you're just saying, well, there's a plane, so I don't need to. I mean, there's not a physical composition of magnetism in a plane. Is that what I'm seeing here? Just because, yeah, it's a topological theory to have lines of magnetism. It seems like it anyway. So
Or I'll try to do this evolution. Not listen to my video later because this was not a good video. But yeah, molecular biology. I mean, that's what I was just trying to, I guess, propose. Like with somebody would say something about molecular biology just to really, I guess, understand this magnetism thing. But yeah, I know I've heard before that magnetism is just there's not an answer for it, and yeah. So I mean, at least I kind of was thinking about the volcanoes and the glaciers and the mixing and just the cooling and the cooling process of that and highest amounts of entropy like nuclear decay essentially. um, um, that's what's happening with essentially static state Big Bang. But then you have, I mean, well, if there is like if the volume's the lowest and the temperature is the highest, there must be like a ground for like a meeting, like I don't know, what's the word, like homeostasis or an equilibrium for that nuclear energy to maybe fuse together into bits, or sorry, into like bits of prokaryotes, whatever. And yeah, so that's this Hadean age. I didn't really get into anything else other than how there's more. I think I wanted to with one Neanderthal, like the extinction, why the Neanderthals went extinct. But it seems pretty clear to me that everything was just too cold for nurturing themselves, for feeding themselves, and that's why they said, well, yeah, they essentially ran out of um, food in the upper like Europe places or things like that. And I think I was also seeing that like Pangea. Well, like once the continent started expanding, I don't was it like I want to say maybe 200, like 200 to 100,000 years ago, the continents. That's when they essentially were expanding or expansive enough, and then also there was the ice age 70,000 years ago, and then you're talking about how the north and south poles were collecting water, so there was less water in the oceans, and essentially they were like the Homo sapiens were just able to like move through more land. There would have been more food and things of that nature. And now it's like 70,000 years later, and our oceans are rising again. So, well, because we are going through the cooling and how so the gradual extinction or the main extinction was like I think the main extinction of the dinosaurs was with the actual warming. I'd say. I mean, it just goes warming, cooling. I think, and now we're in a warming again. And yeah, so uh, it was just like the glaciers or whatever were doing better. I don't know. This was a fucking terrible video. But no, I mean, I should try to finish this. So yeah, all like yeah, there was just more gradual. Like there was the cataclysmic asteroid, and then the gradual theory that there's just more methane in the atmosphere, more carbon emissions in the atmosphere, and that's what depleted the oxidation zones. The oxidation zone was depleted, so there was less plant matter and things like that. And there was another extinction, but so like smaller animals were able to survive off of the shrubs and everything, and then I don't think that's in contradiction to the cruciferous boom. Um, there's also like yeah, I also heard there was like a boom before well the boom before the dinosaurs. Yeah, that must have just been in a warming phase where becoming things were so cold before that things were just habitable. So like uh, after the bacteria had formed into plants, and then there's more, and then you have like little sea crawlers, and then you have things that just things like were getting out of control after that. It seems like just so much cooling, and then more evolution, and then so that was like 600, 500,000 years ago. Um, yeah, and then they just got into dinosaurs, and yeah, I think they were saying like man had become, or sorry, Homo erectus.